Okay, so today we'll start with functions in Python. I hope the audio is a bit better today. Uh, okay, so we'll start with functions in Python and about yesterday's homework. So if you guys have any doubt regarding that, we can discuss those at the end of today's class. Okay, so let's start with functions in Python. So why use functions in the very first place? So suppose we need to execute the same piece of code again and again. So will I write that same code? Will I keep repeating to write the program again and again, the same piece of code, the same segment of code again and again? No. So what do I do? Instead, I use a function so that I can use this code whenever and wherever I require. Okay. So first we define the function using the keyword def, and then we write the function name, and within brackets, within these within the brackets we have these parameters or argument list, that is the functions we or the parameters or the values that we will pass to the function when we call the function. Or I'll describe what is calling a function. Just let me write the structure first. So this is a function that performs the addition of two values. Okay, so let's store the addition in something. Then we have something called the return statement. Okay, so what is the return statement? So if we want to send the output created in this or the output calculated in the function to the place where this function has been used originally, we use the return statement. Okay, for example, uh, I have declared this. Now say I want to write at uh, at result. Okay, so this add and within brackets 2 comma 3 is where I have called the function. Okay, this is where I have called the function. Now what happens? This function calling. Okay, so when I call add function, I have passed two parameters into it, and this will go into this coding block. Okay, so x receives the value of 2, y receives the value of 3, and then we calculate it sequentially. That is, I calculate z is equal to x plus y, 2 plus 3 equals to 5. Then, okay, here I can return z itself. I can return z. So, what is z5? This 5 will be sent to add result. Okay. How does return actually work? So the return keyword basically just sends the value or the output inside the function to the caller. What is the caller here? This at 2 comma 3. Okay, this is the function of return. Did you understand on that? Hello Mandar, are you there? Can you? So this itself is an example. Okay, So if I don't return anything and I just write this, see, this will not give any result. It shows none. Why? Because the value of z has not been sent to the caller. What is the caller? Add 2 comma 3. Okay. So this calls the function. So until and unless I use the return statement, it won't send the value to its calling position. Okay. And also the return statement marks the end of a function. Okay. So if I calculate z equals to say z plus 5. So the current value of z should be 10, but it will always print 5 because whenever the whenever the value the return statement is encountered, it marks the end of the function. Clear? Okay. So let's write what does the return statement do. The return statement cool. Do I get a thumbs up that everybody has understood this? Please mention in the chat once if you have understood this or if there is some doubt. Oh, yes, I can explain it again. No worries. So, okay, I will explain it again. Okay, so what first is when do I need to use a function? I will use a function when I want to reuse a certain block of code or certain segment of code. Cool. Now, see, this is how a function looks. Okay, cool. Now, what I will do is how to declare this function. Okay, first we say we use the keyword def. It means we are defining a function named add. Okay, so what does this add function contain? It will take input as two parameters x and y, which will be used for some operation in this function. Okay, so in this function, then I will use I just want to perform addition. So I am using this plus operation. I am storing the result of the addition in Z. Okay. I'm storing the result of this addition in a variable called Z. And then I am returning the value of Z. So what does this return? Okay. You can consider that suppose you are assigning a job to some student. Okay. You want the student to do the following task. What do you expect in return? Okay, you expect a solution of that problem, right? So if you are expecting a homework, the student is supposed to solve your problem or some code, whatever. Okay, of that sort. Cool. So this is where you are assigning the task. That is, you are calling the function, and this is the return statement. What does this return statement do? If you want to send some value or the result of this operation from this function, okay, then you will return it to the caller using the return statement. So the return statement, it sends the value of z to the caller. Okay, is it clear now? You can also return x plus y directly over here. Okay, B Nishchita, is it clear for you as well? Ananya has responded that she has understood it now. Okay, cool. Okay, so we can also just return x plus y. What is z plus 5 for? So this is just a random statement that I have used here in this function to denote or to explain that no matter what, whatever you write after the return statement, those lines will not be executed. After the return statement, none of the coding lines in that function will be executed. Cool, Ashaf? Cool. For example, okay, for example, let's keep it like this. If I use z equals to z plus 5, I'll have the value of 10. I'm not returning anything, right? Yeah. So I receive a value of 10 as my output. Cool. But if I execute the same statement here, then I receive a value of 5. Is it okay? Everyone has understood? Oh, okay. So let's see a nice program example for this. Print all the prime numbers within a range. Okay. Say I'll have a lower bound, and upper. Okay. So let's check first. Okay. So what would be variance? Achha, tata. Hmm. So what would be my approach in this program? First, I will lead the lower bound and the upper bound from the user. Okay. So let's write LP equals to int. Okay. So here's a cool thing about input. By input, you can ask the user to input some value. Okay. Whatever be it. By default, the input function takes input as a string. You need to typecast it for your own use into either integer or float or whatever the purpose you are using the variable for. So in this case, let's just consider it to be an integer because the values here denote a range and a range can be better defined by an integer. Okay. So what do I need to do? Obviously, I need to check if each and every variable is an or is a prime number, right? So for I in range, LB, comma, UB plus 1, because I want the upper bound to be included as well, right? So let's see. Now what do I need to check? If if I will individually check if an element or if a number in this range is a prime number. So here I can use the concept of nested loops. But what is a nested loop? A nested loop is a loop in between a loop. Okay. But in this case, let's just focus on using the functions. Why? Because see, using nested loop is pretty complicated. So why complicate your program without any cause as such? Okay, so you should try to keep your code simple. So let's just use a function to check if my number is prime. If it is a prime, then if it is a prime uh, number, then it shall be printed. Okay, so I am using this is prime function. Okay, but where to use it? How to use it? I need to declare it first. Okay, so let's declare it. Def is prime. How many variables am I passing through this function? Just the one. So let's consider a temporary variable, say x. Okay. Now I need to check if it is a prime number. So the code for prime number is pretty simple. The easiest being, if you if no number between 2 till that number can divide itself, can divide the number, then it is a prime number. Okay. So this is what I have used from 2 till x. I will divide x with each of those numbers. If one of them turns out to be a divisor of x, if any number turns out to be a divisor of x, okay, then that is x mod I being 0. Okay. Or if x turns up to be a multiple of that number I, then it will return false. That means it is not satisfying the condition of prime number. Cool. If not that case, yes, I'll explain that again. If not that case, then it will return true. Okay. So oh, let's comment out this part. Let's check if a number is prime number. Okay. And we'll do a dry run of that. And we can do obviously till square root of x. That is sufficient enough to check. But okay. Since many guys are learning programming for the very first time, let's not complicate things. Okay. Cool. So say is prime 5. I want to check. So is prime is a function that I have declared to check if a number is prime or not. Cool. So so to check a prime number, as Aditya has suggested, obviously that if you check from 1, obviously every number divides 1, so not 1, from 2 till the square root of that number. Okay, then if any number between 2 to square root of that number divides the original number, that is consider a number x. If you consider from 2 to square root of x, if any number I belonging to the range 2 comma x divides x, then x is not a prime number. Understood? Okay, cool. So here, what this function is doing, this function, let's see what it's doing. So as I call is prime 5, it will send 5 here. It will send 5 here. So for I in range 2 comma 5. Okay. So first it will for the 0th iteration. Okay, or for the first iteration. Should I write it? Should I write it? Okay, let's write it. What is the value of I? Here, the value of I is 2, since the loop starts from 2. Okay, so it checks if x percentage, that is if x mod 2 equals 0, which translated turns to if 5 mod 2 equals 0. Is it? It is a no, right? False. So I equals to I plus 1. Cool. We then go forward to the second iteration. That is I equals to 3. And we check if x mod 3 is 0. It is not. So false. Now I check for the third iteration. That is when I is equal to 4. Does 4 divide 5? No. Okay, here I equals to 5. Oh, they consider 4. Fourth, it will not run. Okay. So see, despite AI suggestions, okay, they do suggest wrong things, right? So they didn't even imply that when it comes to 4, the loop condition terminates and the loop will terminate. Okay. Okay. So for the third iteration, where we were, for the third iteration, I have I equals to 4. 5 does 4 divide 5? No. So it goes forward to I is equal to 5. Okay. So I equals to 5, loop condition fails, then we get out of the loop and we encounter this return statement, right? Encounter loop condition fails, loop terminates, encounter return true, and return. Okay, is it clear? Clear, is the is prime function clear for the others apart from Mandar? Okay, now let's get back to our program. Okay, so what happens here in our program? Let's revisit. We have taken input the lower bound, we have taken input the upper bound, and then we have started a loop from the lower bound to the upper bound. And why have we considered ub plus 1? Because by default in range we don't get the ub value, we get till ub minus 1, right? So to include the ub value itself we have considered ub plus 1. How does the encounter turn true? One second, but let me just go through this. Okay, so we pick each value, okay, and we check if it is a prime number or not. So if it is a prime number, it will go into this def is prime function. Cool. Now, if the loop condition ends, this is where the loop ends, right? Loop begins here, loop ends here. Aha. Loop begins here. Cool. So, okay. So loop begins here, loop ends here. Now, what do we need to check? If this condition is satisfied. Okay. So if this condition is satisfied, then I enter into the if block, which is return false, and the program ends here. This function ends here. Why? Because as soon as I encounter a return statement, my function comes to an end. Okay, or the function terminates there and then and there itself. But if it is a prime number, then this condition is not satisfied, right? So it will not enter into this block, this if block. Means it will exit the for loop itself after a certain number of iterations. After the for loop, the first statement you encounter here is return true, which means what? That none of the numbers from 2 till x minus 1 could divide x. That means it is a prime number. Since it is a prime number, I have come out of this loop, right? Then I can encounter this statement return true. I encounter this statement return true and it returns the true to its caller. Okay. So let's check. Say I start with 10. My upper bound is 20. So eighth pahla, I get all the prime numbers. So is it clear for you guys? Okay. So next, we shall look into another topic known as while loop. We have already visited for loops yesterday. Today, let's check while loop. Okay. So when to use while loop? When we want to iterate through things until a certain condition is met. Generally, if we calculate something, okay, and we need some inequality to be met, then we use while loop. Okay. So suppose I start with a variable, say I equals to 0. Just like in the case of for loop, for I in range something, the I starts with 0. Let's assume that our while loop encounter variable, you can kind of name these as loop counters. Okay, so loop counter variable. Okay, starts from 0 and until it reaches 5, till the value of I is less than 5, I want to print all those numbers. Okay, so I print the value. Then I need to increment the value of I so that it goes up to the next value, right? Which is automatically done in the case of for loop. Okay, loop counter variable is a counter variable. You can call it a counter variable that determines the step of a loop. What is a step of a loop? The variables or the number of iterations that will take place in the loop itself. Okay, it is the number of iterations that will take place in the loop. Cool. Okay. So if I don't increment the value of I, it will be in a infinite state. Okay, it will always remain I equals to 0, always satisfy the condition I less than 5. It will go on infinitely. Okay, but to encounter I, the loop I can increment it as I plus equals to 1. This also stands for I is equal to I plus 1. Okay, that means I'm incrementing the value of I by 1. Cool. Let's see a dry run first and then check the value. Hmm. If- Okay. So I equals to 0. Does it satisfy the condition? Okay. So it does satisfy the condition. So we print the value of I. What is the value of I? 0 plus I. Yeah, you can write that. I think I plus plus would be the postfix version would be better in this case. Okay, cool. Because if you just write, okay, yes, you can write plus I. Since you're already printing the value of I first, you can write plus I as well. Okay. Yeah, cool. Yes, but you can write it as plus I. Cool. Okay. So now increment the value of I is equal to 0 plus 1, which means I is equal to 1. Now when I equals to 1, 1 less than 5, yes, print 1, I is equal to 1 plus 1 equals to 2. Now I equals to 2, 2 less than 5, yes, print 2. Then no, we don't put enclosed brackets or curly braces after while, because in uh, Java or C or C++, you need to use curly braces to demarcate segment blocks or coding blocks. Okay, but in this case, you don't need to do so. That is done through pure indentation. Cool. Hmm. Okay, see, it has adapted. So it will go on nicely till 4, and then its value will be incremented to 5. So we see if the value of 5 is equal to or less than equals to 5. It is not less than 5, right? Okay. So we check if the value of 5 is less than 5, which is obviously not. So the loop terminates here. Okay. Now if I execute this, you get 0, 1, 2, 3, 4. Cool. Any doubt regarding while loop? Anybody with the teeniest of doubts? Okay, cool. So let's try a program using while loop. So till now we are using our base case is function. So we'll use a function here as well. But we have seen an application of function in the case of a for loop, in the case of a while loop. Now we'll see an application of function in the case of while loop. Program to check if a number is an Armstrong number. So what is an Armstrong number? There are many CS guys here, or there are many students who are quite acquainted with programming. So if you can just say what is an Armstrong number. I have tried to keep this class interactive even though you guys are on mute. So yeah, please mention what is Armstrong number. 10 to the power minus 10m. What do you mean by that? Sum of power of digits is equal to the number itself. Shorodipto, you are right. If sum of cubes is sum of digits, actually it should be the number of or the sum of power of every digit is equal to the number. Okay. Sum of power of the total number of digits in the number is, yeah, is equal to the original number, then it is an Armstrong number. Okay. Yeah, Ariana has a better explanation for it. Ah, so sometimes when I speak and I am also simultaneously reading your chats, okay, I get on a pause. Okay. Okay. So final explanation according to Madam Ariana Chatterjee, sum of the digits of a number is equal to sum of the digits of a number, each raised to the length of the number is the number itself, which is what is the length of a number? The number of digits. Okay, now let's see an example. For example, 153. 153 is equal to 1 raised to the power 3 plus 5 raised to the power 3. Aha. Plus 3 raised to the power 3. Okay, so in this case, what is the number of digits? Number of digits is 3. Okay, and we are adding each number, each digit raised to the power of 3. Okay, when you sum each individual digit raised to the power of the number of digits, then it becomes an Armstrong number. Okay, so obviously I'll use a function because using a function is worth it. So let's store this variable into a temporary variable named temp, and we can use that for future operations. Okay, So, how to calculate the length of the number or the number of digits? Okay, so I can just convert it into a string. Okay, then I will use L len n. Cool. Then I have the number of digits. I'll keep a dummy variable sum that will accumulate the sum of each digit raised to the power of 3. Okay. So I need to check each individual digit, how to extract each individual digit. Okay. So the first number is at ones, then it is at tens, then it is at 3. Okay. Then it is at hundreds. Okay. So obviously I can see if I divide this number by 10, I can receive 3 as a remainder, then I can receive 5 as a remainder, then I can receive 1 as a remainder. Okay. So how long should we go? Till the number is 0. Let's calculate the remainders first. Cool. By using pow, I can raise it to the number of digits. Sum is equal to sum plus rem, comma, n. Okay. Then the number becomes shorter, which means 10. Before I had a 3-digit number, then I reduce it to a 2-digit number, to a 1-digit number, and then it will be 0. Okay. We'll understand this explicitly while we are doing the dry run. Okay. But for now, consider it to be my wise words. Okay. So what is this double backslash? I know that single backslash is used for division, right? So why am I using this fancy double slash? I'm using this because it denotes float division. What does that mean? That when you have already used float function in maths, right? Some way or the other. Okay. So if I am dividing a number and the result of division is in float. Okay. If I use the float division operation, it converts it to its nearest lower integer. For example, it is if it is 7 divided by 2, then it should be 3.5. And if it is 7 float divided by 2, then it shall be 3. Okay. Truncate whatever is after the decimal place. That is the purpose of float division. Okay. So were we? Okay. So I have calculated the sum here. Next, I will check. Oh, okay, okay. Thank you, thank you. The number I was using here is temp. Yeah, the variable. So it should be temp. Thank you, Deep. So what do I need to do now? I need to check if this number is equal to the original number. Okay, if the summation of these individual digits raised to the power of the total number of digits is equal to x. So if it is true, then it is an Armstrong number, else it is not an Armstrong number. Okay. So what do I do? I call the is Armstrong number function. Ah, there was a typo here. Hmm. There was another error. That is L. So L is the length of the of the string. So this actually denotes. Okay. So 153 is uh is an Armstrong number. Now let's see some other example, false example. So 121. It is not an Armstrong number. So do you have any example of a four-digit Armstrong number? 1634. 1634 is true. 9474. It is true. Somebody said 370. I'm skeptical about 370. Let's see. Okay. This is also an Armstrong number. 8208. Okay. So our code is working perfectly fine. Nice. Cheers to us. Kudos to us. We have officially mastered functions and while loops and so on. Next, I would like to grow your interest in something known as recursive functions. So dry run, iska. Oh, iska. Oh, ha. Sorry. Ah, we need to do the dry run as well. Okay. Okay. So is Armstrong, say I am passing 153, then x is equal to 153, then which means temp is equal to 153. N is basically converted into a string function. So it becomes a string version of 153 and then L is my 3. Now enter loop. Okay. So when I am entering the loop, first iteration, I have, if I see 153 divided by 10, then this will leave a remainder of 3, right? So my initial sum variable was 0. That means my sum was initialized to 0. So now it is sum plus 3 to the power 3. So in this case, 0 plus 3 to the power 3. Okay. So it becomes 27. Now, when I divide the value of temp, it becomes 15, right? Then I go on to the second iteration. Okay. Similarly, the remainder is calculated as 15 modulus 10, which is 5. Then I add it to the previous sum, that is sum plus 5 to the power 3. It was previously 27. Now it is 5 to the power 3. So it is 27 plus 125 equals to 152. I am again changing the loop counter variable as temp equals to 15 float divides 10, which is 1. Now for the third iteration, I have remainder equals to 1 modulus 10 equals to what? 1. Sum equals to 152 plus 1 raised to the power 3. Okay. Equals to 153. Then I have 1 float divides 10, which is 0. Now, since I encounter temp equals to 0, which is not greater than 0, so the loop terminates. Okay. And then I check is sum equals. Yes, I'll show the code again, don't worry. Next. So if it is yes, it is true. In this case, 153, x was originally 153, so it is true. Cool. Look at the code. Okay. So let's address the question. Shoma of him, is there any attendance link? No, there is no attendance link. Okay. Not as far as I'm aware of. And hey, Shoma, did you previously attend any of these TIH internship programs? Say summer internship 2024. Lakshman, I have shown the code. Mandar, you're welcome. Oh, for Perl, what is double division? Double division stands for float division, which means if it was a single backslash, it would say 3 divides 2. Okay, 3 single backslash 2. Then the result shall be 7.5. But if I use double division, it converts the result into its nearest lower integer, which is 3. Okay, so you get a value of 3 for float divides. Okay, cool. So is there any doubt, anybody, regarding Armstrong number program? Okay. Okay. So now let's look into something known as recursive functions, aka recursion. So what is recursion? Basically, when the function calls itself again and again. Cool. Sorry. So your tomorrow's class will be on object-oriented programming. It will be taken by Dr. Sujoy Kumar Vishwas, and I shall take your class on NumPy and Pandas on Saturday. Okay. So let's look at an example for recursion. Okay. So I guess most of you have been able to do the factorial program yesterday. So what do you mean by factorial? Suppose it is 5 factorial. It means 5 into 4 into 3 into 2 into 1. Okay. What is 4 factorial? It is 4 into 3 into 2 into 1. So what is 2 factorial? It is 2 into 1. Okay. So as you can notice the pattern that to calculate the factorial of x, if you already have the value of x minus 1 factorial, you just need to multiply x with that. This is the approach for recursive programming in factorial program. Okay. So by default, we know that if x equals 0 or x equals 1, return 1. That means the value of x the value of 0 factorial or 1 factorial is 1. Okay, cool. Now, in case of a recursive program, or in case of a recursion, you have two cases. One is the base case, which is this. That means where the case should stop, or where the recursion should stop. And the other is the recursive case. So it is just like induction. In induction, you have initially a base case, and then you go on proving till the end. You assume it is true for n, and then you prove it for n plus 1, right? So it is just similar to that. Especially when you will see the dry run of this, it will be more clear. So this is the code. Let's see. It is 120. Let's see for 6, it should be what? 720. It is right. Now let's see the dry run. I keep it for 5. Okay. Now let's check the dry run. So in the first call, initially, what do I get? Factorial 5. Okay. So as soon as I enter factorial 5, I check, is it equals to 0 or 1? No, right? So it goes into the else section. Into the else section. Okay. Since, okay, let me maintain an indentation as well. Since mm, x is not okay, this denotes not, this denotes equals to, so not equals to 0 or 1, we go to statement return a x star factorial of, it is x minus 1, so it goes to 4. Now when I encounter this function, okay, when I encounter this function, then this function is called, which means I am calling factorial. Here we are not giving print command, still getting an output. Yes, in the case of factorial, since the value is returned here ultimately, so you will get the value. Don't worry. If you want, I can store it there. Hmm. Okay. So now, since I have encountered factorial 4, I call the function factorial, pass value 4. Again, since x is not equals to 0 or 1, then I call x star factorial 3, means x into factorial 3. Okay. So factorial 3 calls this function factorial, passes the value 3, so on. Then it again follows the same pattern and I get the value of factorial 2. Okay. So in case of factorial 2, let me copy this. This factorial 1. Now as soon as I go to factorial 1, I know that I have hit the base case. Okay. So return what? Return 1. That means this function has been done. This function has come to an end. Now, what does the return function do? It sends the value to the caller. Where has it been called? It has been called here. So it returns equals to x star 1, which was 2. That is 2 into 1. Let's replace this as 2. Since it was 2, factorial of 2, it will return 2 star 1, which is equals to 2. Where will this be received? This will be received here. So this shall be 3 star 2 equals to 6. This will be received here. That is 3, sorry, 4 star 6, which is 24. Okay. Here this shall be 5 star what? 24 equals to 120. Thus the function factorial 5 will ultimately return 120. So is the concept of recursion in general clear to you? Anybody, any doubts? No doubts as such? You guys understood recursion so easily. Nice. Generally, people complete the course without understanding recursion. Sir, explain again. Sarthak wants me to explain again. Okay, please explain it again. Cool. So what does recursion do? Recursion calls the same function again and again. Okay. I am explaining it again. Hmm. Okay. So recursion same calls the same function again when it needs to use this. So as we can consider it for this example of 5 factorial. Okay. Consider it for the example of 5 factorial. So what is the value of 5 factorial? It is 5 into 4 into 3 into 2 into 1. Okay. What is 4 factorial? It is 5. It is 4. Excuse me, into 3 into 2 into 1. Right? So can I say 5 into 4 factorial is basically 5 factorial? I can say, right? Right? I can say it. I can claim this. This is my main induction hypothesis for recursion. Okay. So just like induction, in recursion, you have a base case. That is the initial developmental stage or the initial consideration. Okay. So what is the initial consideration for factorial? So if the x value is 0 or the x value is 1, then its factorial is 1, right? So 0 factorial or 1 factorial is 1. Now I somehow need to reach 0 or 1 to get the value. So my recursion statement is x star x into factorial of x minus 1, which is the hypothesis I had got here. Okay. So I will call x into factorial of x minus 1. For this factorial case in recursion, does the value of x goes to 0 or stop at 1? It will, for this case, it will always stop at 1. Even if I omit x equals to 0, since it is a linear depreciation, okay, it means it is a decreasing value by 1. Okay, so eventually after x minus 1, it will, after factorial of 2, it will come encounter x factorial of 1. So once it is factorial of 1, it will return 1. Okay, is it clear, Ishar? Okay, cool. So now I have developed the induction hypothesis as x into factorial of x minus 1. So let's look how does this work. So I'm calling factorial of 5. I want to calculate the factorial of 5. So is factorial is the value of x 0 or 1? No, it is not. So it will go into the else section, which says that 5 into 4. Okay, I had received 5. So it is 5 into 4, 5 into factorial of 4. I need to calculate factorial of 4. So as soon as this function is called. Okay, the same function is calling itself. Before I had called factorial, so the function factorial is calling itself. Okay, but passing the value of 4. So when factorial of 4 is called, so this function is executed, factorial 4. Again, 4 is not equal to 0 or 1. So I calculate 4 into factorial of 3. Correct na? 4 equals to 0 or 4 equals to 1, no? So it goes into the L section, which is 4 into factorial of 3. Okay, so when I get 4 into factorial of 3, I encounter factorial of 3 function. So I go into that. And similarly, it is followed till factorial of 1. Now when I encounter factorial of 1, my x value is equals to 1. So it will return 1. The function is terminated. Fact, please pay a close look to this. Not the entire factorial 5 which I had called at first is terminated. Only factorial of 1 is terminated. Okay. So when factorial 1 is encountered, x value being 1, I am returning 1. So it is terminated. Now where does the return value send its output? It sends it to the caller, which is factorial of 1. Correct? So this factorial of 1 is replaced by the value obtained, which is 1. Cool. So 2 into 1 equals to 2. Okay. Now I get into factorial 3 because why? This factorial of 2 will return its value over here in this factorial where it had been called. Right? So factorial of 2 is replaced by 2. So 3 star 2, 6. Now factorial of 3 will return its value where 2 factorial of 3. Okay, where factorial of 3 has been called. So what did it return? It had returned 6. Okay, so 4 times 6 is 24. Okay, so I am returning a value of 24 from factorial 4, which is received here where the position where factorial 4 had been called. Now it is 5 times 24 equals to 120. So the entire recursion is done. Now is it clear? Other responses, please. Even if you have a doubt till now, I am ready to explain it again. Okay. What do I take this silence for? Clear. Okay. Okay. So now we will look into more advanced operations of lists. Okay. So first is an operation called append. What does this mean? It means at the end of. We can also do this with for loop. Yes, we can do this with for loop, but there are many such programming instances you might encounter in future where recursion comes in really handy. Okay. So if you study this course, ever say design and analysis of algorithms, you'll see that in many cases, using recursion proves to be an advantageous situation over normal loops. Cool. So if I have a list, say mine is equals to print the original list first. So as you can see that I have added the number 25 into the list at the end of the list, right? So now we can also remove an element. So we can also try to remove an element, say mind list dot remove, uh, say 6. Oh, okay. Oh, just tell me one thing. When I was writing this thing, okay. So did you have that white colored chat box in the middle? No. Okay, cool, 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 cool. Nice. Mm. As you can see that the sixth element has been removed. Okay. So if I write 7, the first 7 is removed. If I write say 10, element at position 10, okay, it is not in the list. So, what do I want? Okay, not from any position. So it removes an element from the list. From the list. Okay. So if I write 7, it will remove only the first occurrence of 7. Okay. If I write 25, it will remove 25. Cool. Have you used camel case? Yes, I have used camel case for my list. So why is it called camel case? Because you start with a lowercase, then to demarcate the beginning of some new keyword, you use the first alphabet to be in uppercase. Okay, so since this hump, it is called a camel case. Okay, it is called camel case. So next we have pop function. Pop an element dot pop. Say what should I write? First see what is the default setting in this case. Okay, so by default it removes the last element from the list. Okay, but mm, how about say I write 7, then it will remove the remove the element from the mentioned index. By default removes the last element of the list. Okay, so what is list dot remove? List dot remove is you can, or you can say removes the first occurrence of a value. Hmm. Cool. Is it clear? So number at index 7 was 8 and I have successfully removed it. Right. Okay. So you can also update the values at any list. Say, so this is why lists are called are called mutable, because you can perform some mutation. What is the mutation? You can update its value at any location. Say I write my list 3 equals to 300, then I see that the third index element has been changed to 300. Cool. I think this is also clear. Now we can also perform some list comprehension techniques. So suppose you have many fruits named apple. So you want to have elements in the new list, say, of fruits containing A. Okay. So first we iterate through each fruit. Okay. So if I encounter the character A in string X in the string X, then it will be added into the new list. Okay. So this is pretty easy as well. Okay. An alternative way is a simple new list equals to X for X in fruits if A. Okay. So is this clear till now? Any doubts? It means that I am declaring an empty list. Declaring an empty list. Any other doubts, anybody? Which part? Which part should I repeat, Paul? List comprehension. Okay. So suppose you want to perform any operation that involves the individual elements of a list. Okay. So for example, I want to to store the name of fruits having an A to into a new list. Okay. So I iterate through all the elements in the list, which is through for x in fruits. That means when x is equal to 0, the zeroth element in fruit is apple. So I check if A is present in apple. Okay. So my x was apple. Okay. So I ask if A is present in apple. Okay. If A in apple, if it is, then add it to the new list using append. Okay. Now this same task can be done in a single line as well. What does x means here in this case? That means from the loop, from the condition satisfied, you select the x value. Okay. For what? For x in fruits. Okay. For x in fruits, which is just the loop statement, right? If a is in x, if a is in x, then this new list.append x is done through x. This basically means that you select the values of x that satisfy a condition. And what is the condition? That is declared here. Here? Okay. Does anybody else have any doubt? Okay. So next we come across a data structure known as dictionary. Okay. So what does this do? This data structure contains element in a p-value pair. Okay. So this is what my dictionary looks like. Okay. So what is a dictionary? It is a data structure in Python that stores elements in the form of key and values. Now what is key? The key here is the left hand side, which is Harry in this case. And what is the value? It is in Gryffindor. So value is Gryffindor. Cool. Now how to access as an element? Let's see if what we had tried previously works in this case. So suppose I write Hogwarts 1. So that does not work here, right? How can I make that work? I need to, okay, that object is not subscripted. Just a sec. Hmm. Aha, so many typos. Where is this error? Okay, this is considering it to be a set. Hmm. But why is this a set? Last time I had checked it is a dictionary. Okay, okay, got it. So my mistake was I had kept them under the same set of commas. Okay, now it will work completely fine. See, yeah, those are strings. Hmm. Yes, so the key string and the value string, these should be separated by a colon. Okay, so now this will work completely fine. Okay, so suppose you want to enlist all the keys present here. How will you do so? Using the keys functions. And by values, you can print all the values present in the string. Okay, so now you want to update some value. You can do it in this manner. Okay, now also let's try Okay, so the usual type of syntax does not work. So next we look into something known as tuples. So similar to lists. So this is similar to lists, but not mutable, but immutable. That means you cannot perform any updations here. Okay, cool. Say I write my tuple equals to how is the dictionary stored in memory? It is stored in a key value pair. For each key, you have its corresponding value. Can you share out the link at the terminal then? Yes, I will share. I hope you have received last day's uh, notebook. Doipan had just asked. Hmm. Okay, so coming back to the original problem, how is the dictionary stored in memory? Okay, it is stored in a very typical format, that is key and value. Okay, so you have these things known as hash tables. Okay, for that you have an index value, and with that you have a corresponding value to it. Okay, so it is stored in a similar value, similar format, just like index in your book. Okay, cool. It is an advanced data structure. Okay, so you won't understand that until and unless you have taken a course of data structures and algorithms. Cool. Mm. Cool. Okay, so now what do I do? My tuple 0, I got the evaluated 0 at the index I can, but I cannot update itself. For example, if I say my tuple 4 equals to 100, print my tuple, then there will be an error. Okay. Now, can you suggest some technique so that I can update a tuple? Anybody? Convert into convert tuple to list, update, then convert back to list. Exactly. That is the approach we will take. Okay. So my tuple equal to list my tuple. Cool. So far, so good. So far, so good. Okay. So next, we look into set. Also, let's just keep a track of the notations. For lists, it is third bracket. For tuple, it is single bracket of first bracket open, first bracket close. For sets equals to, it is third bracket open and third bracket close. For dictionaries, it is third bracket open close with a key and value. Okay. Here. Okay. So what is a set? Anybody? What is a set? Set is a collection of unordered distinct elements. That means that the set elements order does not matter. In a set, the order does not matter and they must be distinct. Okay. This is the shortcut we can consider. Yeah. So if we write, say, my set 1, 2, 3, 4, 5, 6, 7, 7, 8, this will eventually boil down to 1, 2, 3, 4, 5, 6, 7, 8. Correct. What are the other operations we can do? We can perform add. We can also perform remove. Okay. So as you can see, it is very trivial that I have added the number 9 into the set and I have also removed the number 9 from the set. Okay. So, and if I want, I can also use typecasting over here. Say, uh, so how about we print that version? Does that affect? Okay, since it was already a set, it did not print the multiple occurrences. Also, Oh, I need to store it somewhere. Hmm. How I say my list equals to can I put this here? Then then there's no point in doing this experiment. Okay. Okay. Or maybe I could just hmm, or maybe I could just do this very trivial stuff. Or we can see if after conversion to list. Hmm, wonderful. So as you can see, as soon as I have converted it to set, then the occurrences have been removed, thus fulfilling the set properties. Okay, so far so doubt, so far so good. Do you guys have any doubt? No doubt, no doubt. Cool. Also, you can use math functions, math methods. So this is called you're importing a module. So, okay. So what is a module? A module is an inbuilt library in Python. Okay. What do you mean by importing it? You're calling the module and saying that I will be using various functions from it. Okay. So I have imported the module and then you say that I've imported the module math and I am renaming it as M. Cool. So what are some common operations? M dot say sqrt. Okay. The square root function. You can also use the round function. Okay. So in round, if you have at 0.50, it remains the same. It is converted to the lower version. If you have it at 0.49, then obviously it will be a 50. Okay. So if you also convert it to round 0.51, then it will round it to 1, right? Yes. But if you see, if you put it as 5, 0.501, slightly greater than the mid value, then it will be converted to 1 itself. Cool. You can also use several math functions. For example, if you want to find the value of say 45 degrees. Okay. Say cos 45 degrees. Then let's say I'm using round. I want to find the cos value of what? 45 degree. How do I represent it in radian form? I'm calling the pi value and I'm dividing it by 4 and I want it to be rounded off to 3 decimal places. So I write a 3 and we are done. Cool. Any doubts? No. EMA 3, sir, why not m dot round as m dot sqrt? What do you mean? Why round? Because I want to round off a value. M dot sqrt, these are two separate functions. Oh, okay, okay. M dot round. Ah, you can use both. Sometimes you need, this depends on the Python version. Okay. Sometimes you need to import the math function. Sometimes you don't. Okay. This completely depends on the Python version. Okay. So in the older versions, I guess math has, okay. So now it has been excluded from uh, the math functions. But previously, I guess it was a part of the math function. Okay. So far, this is it. So do you guys have any doubts? Then I'll explain that part. Otherwise, I'll end today's class. Why you are we writing m before cos? So we are writing m before cos because cos is a function or is a method of the math module. Okay. Oh, I was not writing m before dot pi. Okay. Not, I was not writing m before pi by 4. I was just writing m before pi. M dot pi, the value is declared, system declared by the processing, by the Python module itself. Cool. So any feedbacks that you would like to share that I need to improve on for the next class or so? So you still have two classes left for me. Homework. So you want homework? Okay. I don't have any homework prepared for now. I shall mention it. I shall mail it to Miss Bidisha and she might forward it to you. Can you please show the set area for a minute? Okay, sure. Reset. Yeah. Veronica, is it clear? Do you have any doubts in set? Where can we find? Will we be given the link? Sir, wait, okay. Can we find more practice problems on this? Where can we find? You can find it on W3 Schools, HackerRank, LeetCode, etc. etc. You will find several websites. I think the go-to would be HackerRank. There's a Python module in, there's a Python course in HackerRank. You can try out the problems there. Okay. Will we get the link of the collab sheet? Yes, we'll definitely get a link of the collab it's not Colab sheet, it's Colab notebook. Okay, so we'll get a link for that for viewing, and it will be shared. Where to use mutable ones and where to use immutable ones. So in cases where you want to update, you want uh, that you need to update some value later on while using, you should use the mutable ones. But if you want to keep the initial set as a constant one, then you should use immutable. Tic-tac-toe game using Python. Wonderful. Good. I encourage you all to try different programs. You can uh, play with whatever you are being taught in the class. Okay. So cool. If you guys do not have any more doubts, then I shall end uh, today's class. Any more doubts? Okay, seems like a no. So we shall end the recording.